Hello, so today we're going to have a look at ionic bonding. Now please make sure your phone is off, you've not got any other screens on to distract you, and you've got a pen and paper to take some notes. So ionic bonding, first going to look at what it is. And it happens between metal ions and non-metal ions. That's where we get that term ionic from. It's between ions. And I can hear you asking, how do atoms become ions? Well, don't worry, in case you've forgotten, we're going to show you very, very quickly. So, first off, we have a magnesium atom here. We know it's magnesium because we can count the number of electrons that it has. Magnesium is in group 2, so it has 2 electrons in its outer shell. When it becomes an ion, we can see that those 2 electrons have gone. They've come over to here now. They've come over to this side. So we now have a magnesium ion with a +2 charge, and we have 2 electrons over here that have a -2 charge. And what is happening is each atom will either lose or gain electrons to have a full outer shell. We can see that magnesium has lost 2 electrons to have a full shell. There'll be no point in it losing 1 because it would still have an electron in that outer shell. It wants to have a full outer shell. Now you might be thinking, well, how do we work out what kind of charge an ion has? Simple rule, we have metal ions have a positive charge because they lose electrons. I know it's backwards, it's just really messed up. You feel that because they're losing it should be negative, but we're looking at the number of protons versus electrons. Numerous ways we can work it out. We can try and count them all, or we can just go, I need to remember positive charge is losing electrons. And non-metal ions do the opposite. They have a negative charge because they have gained electrons. So if we look at the elements on the periodic table, we know that group 1 atoms make ions with a +1 charge. They have lost 1 electron. Group 2 atoms make ions with a +2 charge. They have lost 2 electrons. You can see where we're going with this, well done. And group 3 atoms make ions with a +3 charge. And that is because they've lost how many electrons? That's right, they've lost 3 electrons. Well done. Now that's our metal ions. They're fairly easy to work out. We go, group 1 is a +1, group 2 is +2, group 3 is +3. Pretty easy to work out. Our harder part comes for the next bit, the group 5, 6 and 7 atoms. Now they make ions for group 5 with a -3 charge. The reason why it's -3 is because they have gained 3 electrons. They've got 3 more negative things, their charge is now minus. The reason they've gained 3 electrons is because they want to have a full shell. If we think about the group 5 elements, they have 5 electrons in their outer shell. They want to have 8. They want to get up to that magic 8 number. So we need to get 3 more electrons. We need to gain 3 electrons to make a full shell. Because we've gained 3 electrons, we have a -3 charge. For our group 6 atoms, they have a -2 charge. And you've guessed it, that's right. That's because they have gained 2 electrons. Well done. And our last one, our group 7 atoms make ions with a -1 charge. And again, well done for getting it right. They gain how many? They gain 1 electron. Because they've gained 1 electron, they have a -1 charge. Really well done so far. I know this stuff is tricky. Well done for sticking with it. Got a little demonstration here of what is happening. So we have our sodium atom is losing that electron and is giving it to fluorine, which is gaining 1 electron. So we might say that ionic bonds are due to the transfer of electrons. I'm just showing you how we draw it at the end. We draw those brackets around it and put their charges on to show what they are. I know you can all do that. I'm sure when we're back at school, all your teachers will go over this again with you, just recapping it all. We're now going to do a bit on working out the formula for ionic compounds. Now, what I'm about to show you, I'm not entirely sure is strictly allowed by the government for me to teach it to you, because it works so well and they don't like people finding easy ways to do things. So please don't tell your parents that I taught you this method. Please don't tell your other teachers. Please don't tell Mrs. McCready. Please don't tell Mr. Devaney that I've taught you this way of doing it. So, looking at it then, when we work out the formula for ionic compounds have no overall charge. The charges cancel out. They are neutrally charged overall. That's because the charge on the positive and the negative ions will cancel each other out. And we've already looked at how we work out the charges on them. We're now going to work out how we work out the formula of an ionic compound. And I'm going to show you this really, really easy way of doing it. It's called the swap and drop. We're going to start off, we're going to look at sodium chloride. So first off, we need to know our charges on our ions. Now sodium is in group 1, so it has a +1 charge. Chlorine is in group 7, so it has a -1 charge. When we make our compound, we need to have the right numbers so that they will cancel out. To do that, we swap our numbers around and drop them down. So this 1 from up here comes down to here. This 1 from over here comes down to here. And I write them down. So I have Na1, Cl1. Now you might be thinking, oh, actually, yeah, when I write out a formula, if I just write Na, that means I've got 1 sodium. If I write Cl, that means I've got 1 chlorine. And you're right. So all we have to do for this is write NaCl, and we are done. Nice and easy like that. We're now going to have a look at magnesium oxide. So magnesium is in group 2, has a +2 charge. Oxygen is in group 6, so it has a -2 charge. We're going to do the same thing again. We bring this 2 over to here, from the magnesium down to the oxygen, and we bring the oxygen over to here, down by the magnesium. We've got Mg2O2, so we can write Mg2O2. Now actually we can simplify this, because this is just telling us the ratio of magnesium ions to oxygen ions. If I've got 2 magnesium ions for every 2 oxygen ions, well, it means therefore as well I can simplify it, because these numbers are the same. I can halve it down and I can go Mg1, or try Mg, and O1, or O. And this gives me magnesium oxide, so MgO. If I wrote Mg2O2, that is correct as well, but we would prefer MgO. We're just simplifying it down. Now, having a look at another one, so aluminium oxide. Getting a bit trickier now. Now aluminium has a charge of +3. It's in group 3, so it has a charge of +3. Oxygen has a charge of -2. It's in group 6, so it's -2. We're going to do the same thing again. I'm going to take this 3, I'm going to bring it down over by the oxygen. I'm going to take my 2 from here and bring it down to here and put it down there by the aluminium. I can now write it out. I've got aluminium 2, so Al2, and O3. I'm looking and seeing if I can simplify that in any way. Don't think I can. I can't get 2 and 3 to be any smaller, so I'm happy with that one. Our last one, we have aluminium or sodium sulfide. So sodium, as we already remember, is in group 1, so forms a +1 charge. Sulfur is in group 6, so forms a -2 charge, same as oxygen does. Again, I'm going to swap my numbers over. So I'm taking this 1, I'm bringing it down here for my sulfur, and my 2, I'm going to bring it down here for my sodium. That gives me, when I write it out, Na2S1. I don't need to write that 1. Change that to a 1 there. I've written S there. So 1 there. So we get Na2S, and that is my equation for aluminium sulfide. Again, please don't tell anyone that I've taught you this method. Finally, we're going to have a look at some properties of ionic compounds. So they form giant lattice structures. What I mean by that is it looks like this, forms a regular pattern. So we have a regular pattern. For this one, sodium chloride, we can see that we have each sodium is bonded to, or is attracted to, chloride ions in all directions. We get a strong electrostatic force. We get a regular pattern. It's why ionic compounds will form crystals or crystal shapes, because they form this regular pattern. They have a very high melting point. The reason why they have a very high melting point is because of the strong electrostatic attraction, or force we could say as well, between our ions. It's very, very hard to break that attractive force, so they have a high melting point. Ionic compounds do not conduct electricity when solid, because in this shape all of the ions are fixed in position. So the ions are fixed in position and they cannot move. However, if we were to melt it, so turn it molten into a liquid, or aqueous, dissolve it in a liquid, they do conduct electricity, and that is because the ions are free to move. They can now move. A really, really important thing, hopefully you've noticed through this, I've referred to ionic compounds and not ionic molecules. I'll leave you with this lasting thought. There is no such thing as an ionic molecule. Any of you write that in any of your exams, I'm going to be coming for you. There is no such thing as an ionic molecule. Thank you very much for listening. I hope it's been informative. Any questions, do ask your teachers or myself. Thank you very much. Have a good day.